Hello and good morning to all. My name is Prinkal and I am pleased to present my MSc dissertation project titled Urban Disturbance Monitoring Tool using Twitter Sentiment Analysis to Predict Urban Crime. This research was conducted at the Leeds Beckett University under the supervision of the Dr. Jacqueline Campbell, whose guidance and expertise have been instrumental throughout this journey. So, to introduce my project, the urban crime remains a persistent challenge for law enforcement, urban planners, and communities. Traditional crime monitoring methods often rely on historical data, which can delay response times. With the growth of real time social platforms like Twitter, Facebook, Instagram, people frequently share their experiences, including safety concerns and crime observations. This presents an opportunity. Can public sentiment, as expressed on Twitter, serve as an early signal for urban crime trends? This project explores the very question, combining natural language processing, sentiment analysis, and machine learning to build a predictive model for crime likelihood. So, for this project, the aim of this research is to enhance crime prediction in urban areas using sentiment analysis from Twitter data. To support this aim, I defined six objectives. First, to acquire and pre-process crime-related tweets. Second, to analyze sentiment using NLP techniques. Third, to correlate this sentiment with official crime reports. Fourth, to engineer feature and develop a predictive model. Fifth, to evaluate the model using standard performance matrices. And finally, to extract actionable insights for city authorities and safety planners. So for the methodology, a hybrid methodology was adopted combining CRISP DM and Agile frameworks. CRISP DM structure the workflow across phases such as business understanding, data preparation, and evaluation. In parallel, Agile principles guided iterative development, stakeholder engagement, and prioritization of the feature using the Moscow method. Stakeholders include law enforcement officials, urban planners, and data scientists. Their involvement ensures the solution aligned with the practical operation needs and remain adaptable throughout the project lifecycle. So, for the data collection and pre-processing, uh, to comply with the GDPR, I use the fake data which I am generating with the Python module, which is random module which can generate the tweets with the keywords regarding crimes. But for the project we can do tweets, we can collect tweets using Twitter API and with the geotags, as well as we can define the city boundaries. After the data was filtered, cleaned and normalized, stop word links, emojis were removed or translated, non-English tweets and bot generated content were excluded to maintain quality. Tweets were stored in the MongoDB database, a document-based database well suited to handling the flexible and semi-structured nature of Twitter data. Simultaneously, historical crime reports were sourced from open data portals and aligned with the tweet's timestamps and location for correlation analysis. So for the sentiment analysis and feature engineering, for the sentiment analysis was centered to this research. Initially, I used the lexicon-based model TextFlow to assign polarity scores to the tweets. Based on these scores, tweets were categorized into positive, neutral, or negative sentiments. To improve nuance and handle complex language like sarcasm, slangs, I later incorporated a fine-tuned BERT model. This dual-stage approach balances efficiency and accuracy, enabling real-time processing with deeper semantic understanding. Only public and anonymized data was used, and tweets were never attributed to specific individuals. So for the model development, So for the model development, using the process label data, I engineered features such as sentiment trends over time, tweet density by region, and temporal patterns. A random forest classifier was chosen due to its robustness and interpretability. The model was trained to predict whether a location, time, and pair would correspond to a crime event. Evaluation metrics included accuracy, precision, recall, and F1 scores. Notably, the model demonstrates the strong predictive performance, especially in identifying high-risk zones based on negative sentiment spikes. So for the visualization, analytics played a critical role in both interpretation and stakeholder engagement. Sentiment distribution charts illustrated the emotional landscape of the city. Time series plots showed noticeable spikes in negative sentiment prior to recorded crime incident. Geospatial heat maps visualize concentration of distress signals. These visual tools reinforce the model's output and served as intuitive interface for the decision makers to identify emerging disturbance. So for this project, my ethical consideration were the which were the heart of this research. All data was anonymized and handled in accordance with Leeds Beckett University ethics guidelines. No personal identifiers were collected or stored. The model is designed to complete, not replace human decision making, and all results are presented as probabilistic insights rather than deterministic claims. Transparency, accountability, and respect for privacy were upheld throughout the project. So, for the future work, to conclude, this study demonstrates that Twitter sentiment analysis offer promising support for the urban crime prediction. By fusing real-time social data with traditional crime statistics, we can build early warning systems that enhance public safety. Future enhancements could include real-time deployment integrated with 999 call data, multilingual support, and the user-friendly dashboard for the city officials. With further development, this tool could serve the scalable solution for the modern urban surveillance and response. And finally, I would like to sincerely thank my supervisor, Dr. Jacqueline Campbell, for her continuous encouragement and expert guidance. I also express my gratitude to Leeds Beckett University for providing the resource support and academic environment that enabled the research to thrive. And thank you for your attention. I welcome any questions, feedback, or discussion. Please feel free to connect with me. And for the project demo, I would like to show my code working. So for the coding part, I use the Git for version control. I have completed the perfect timeline for the events and coded it perfectly. The code runs on threading, so it doesn't load the machine. It is very lightweight because it runs on separate threads. And I have created the model to train itself when it predicts the sentiment. It goes to BERT model. It again predicts the data and compares it to the current his sentiment to the predicted sentiment, and if they match, it will train together. So in a moment we will see the graph popping up. Right now my code is putting new tweets in the MongoDB database, and another piece of code is retrieving that new tweets in live feed and predicting the data about the sentiment score. It is going through the two-step process. Here you can see the blue dots are appearing. If the sentiment goes above 0.25 threshold, it will blink red. That is very high likelihood of the crime happening there. And We can just feed the Twitter API to the model and it will work the same. Thank you for your cooperation and watching. Thank you.